Linux has quietly become the backbone of the internet, powers most smartphones through Android, and runs the majority of cloud servers worldwide. The question isn't whether Linux is redefining operating systems, but rather how deeply it has already transformed the entire computing landscape. At its core, Linux represents a fundamentally different approach to software development. Unlike proprietary systems controlled by single corporations, Linux is open source, meaning its code is freely available for anyone to view, modify, and distribute. This collaborative model has attracted thousands of developers worldwide who continuously improve and adapt the system for countless use cases. The numbers tell a compelling story. Linux dominates the server market with over 90% of cloud infrastructure running on Linux-based systems. Every major cloud provider, from Amazon Web Services to Microsoft Azure, relies heavily on Linux. The operating system has become synonymous with reliability, security, and flexibility in enterprise environments. Mobile computing reveals another dimension of Linux's influence. Android, built on the Linux kernel, powers more than 70% of smartphones globally. Billions of people interact with Linux-based systems daily without even realizing it. This ubiquity demonstrates how Linux has moved far beyond its origins as a hobbyist project. The rise of containerization and technologies like Docker and Kubernetes has further cemented Linux's position. These tools, which allow applications to run consistently across different computing environments, are built primarily for Linux systems. Modern software development increasingly assumes a Linux foundation. Artificial intelligence and machine learning workloads show a clear preference for Linux environments. The flexibility to customize system resources, combined with robust support for specialized hardware, like graphics processing units, makes Linux the platform of choice for AI research and deployment. Major AI frameworks and tools are developed with Linux as the primary target. The Internet of Things presents yet another frontier where Linux excels. From smart home devices to industrial sensors, Linux variants power countless connected devices. Its small footprint and adaptability allow it to run on everything from tiny microcontrollers to massive supercomputers. In fact, all of the world's top 500 supercomputers run Linux. Edge computing, where data processing happens closer to where data is generated rather than in distant data centers, increasingly relies on Linux. The operating system's efficiency and real-time capabilities make it ideal for processing information at the network edge, whether in autonomous vehicles, smart cities, or industrial automation. Security considerations favor Linux in many scenarios. The open-source nature allows security researchers to identify and fix vulnerabilities quickly. While no system is immune to threats, the transparency of Linux development means issues can be addressed by a global community, rather than waiting for a single vendor's response. However, Linux faces ongoing challenges in the desktop market. Despite improvements in user interfaces and application availability, Linux holds only a small percentage of personal computer market share. Windows and Mac OS continue to dominate consumer desktops, partly due to established software ecosystems and user familiarity. The gaming industry, long dominated by Windows, is gradually warming to Linux. Valve's Steam Deck gaming device runs on Linux, and compatibility layers now allow many Windows games to run on Linux systems. This shift could gradually erode one of the last major barriers to wider Linux adoption on personal computers. Corporate backing has strengthened Linux's position. Companies like Red Hat, SUSE, and Canonical provide commercial support and development resources. Even Microsoft, once hostile to Linux, now embraces it, contributing to the kernel and offering Linux distributions through its Windows subsystem for Linux. The future of operating systems appears increasingly diverse rather than monolithic. Rather than one system dominating all computing, different operating systems excel in different domains. Linux has carved out dominant positions in servers, mobile devices, embedded systems, and high-performance computing. Emerging technologies like quantum computing and neuromorphic processors will require operating systems to evolve dramatically. Linux's adaptability and open development model position it well to embrace these changes. The collaborative nature of its development allows rapid experimentation with new hardware architectures. The concept of the operating system itself is evolving. Cloud-native applications often abstract away the underlying OS, focusing instead on containerized environments. In this paradigm, Linux serves as a thin, efficient layer that manages hardware resources while applications run in isolated containers. Linux has already redefined what an operating system can be. It demonstrated that collaborative open-source development can produce software that rivals or exceeds proprietary alternatives in quality and capabilities. This model has influenced countless other projects and changed how we think about software creation. The operating system landscape of tomorrow will likely feature Linux prominently, not as a single monolithic system, but as a flexible foundation adapted for countless specific purposes. From the smallest sensors to the largest data centers, from everyday smartphones to cutting-edge research facilities, Linux has become the invisible infrastructure of modern computing. The future of operating systems isn't about one system replacing all others, but rather about adaptable open platforms that can evolve with technology's relentless pace. In that future, Linux has already secured its place as a fundamental building block of digital infrastructure.